The Aurora Borealis, or Northern Lights, is one of nature's most spectacular displays. These vivid light shows paint the night sky with hues of green, pink, red, and violet. The term Aurora Borealis is derived from the Roman goddess of dawn Aurora, and the Greek name for the north wind, Boreas. This phenomenon predominantly occurs in high-latitude regions around the Arctic and Antarctic. But what exactly causes these mesmerizing lights? Understanding the northern lights begins with the sun, our closest star. The sun constantly emits a stream of charged particles known as the solar wind. When these particles collide with Earth's magnetic field, they create a natural light show that leaves spectators in awe. The journey from the sun to Earth sets the stage for the mesmerizing dance of lights. The interaction between solar winds and Earth's atmosphere is a beautiful example of cosmic forces at play. This essay will unravel the science behind the Aurora Borealis, exploring the fascinating mechanics and cultural significance of this celestial marvel. Solar winds originate from the outer layer of the sun, known as the corona. The corona is incredibly hot, with temperatures reaching millions of degrees Celsius. These high-energy conditions cause particles to escape the sun's gravity and race through space. This continuous flow of charged particles is what we call the solar wind. As solar winds travel through space, they carry with them vast amounts of energy. When these winds encounter Earth, they are met by our planet's magnetic field. The magnetic field acts as a protective shield, deflecting most of the charged particles. However, some particles manage to penetrate this shield, especially near the polar regions where the magnetic field is weaker. The interaction between solar winds and Earth's magnetic field generates electric currents. These currents travel along the magnetic field lines towards the poles, where they enter the ionosphere. It is here, in the ionosphere, that the magic of the northern lights begins to unfold. The ionosphere is a layer of Earth's atmosphere that is filled with ions and free electrons. When solar wind particles collide with the ions in this layer, they transfer energy, causing the ions to become excited. This excitement leads to the release of photons or light particles, which create the dazzling Aurora Borealis. Earth's magnetic field is essential for the creation of the northern lights. This invisible force field originates from the movement of molten iron within Earth's outer core. The magnetic field extends from the planet's interior out into space, creating a protective barrier against solar winds and cosmic radiation. When solar winds approach Earth, the magnetic field directs the charged particles towards the poles. This is why the auroras are most often seen in high-latitude regions like Alaska, Canada, and Scandinavia. The magnetic field lines converge at the poles, guiding the solar particles into the ionosphere where they can interact with atmospheric gases. The strength and structure of Earth's magnetic field can influence the intensity and location of auroras. During periods of increased solar activity, such as solar flares or coronal mass ejections, more charged particles are released. This can lead to stronger and more widespread auroras, sometimes visible at lower latitudes than usual. The magnetic field not only directs the particles, but also plays a role in the colors of the auroras. The energy and type of particles that enter the atmosphere determine the specific hues that we see. This interaction highlights the intricate dance between solar winds and Earth's magnetic shield. Atmospheric fluorescence is the process that makes the northern lights visible to the naked eye. When charged particles from the solar wind collide with gases in Earth's atmosphere, they transfer energy to these gas molecules. This added energy excites the molecules, causing them to emit light when they return to their original state. The ionosphere, where these interactions predominantly occur, contains several types of gases, including oxygen and nitrogen. Each type of gas emits light at different wavelengths when it becomes excited. Oxygen, for example, produces green and red lights, while nitrogen can create blue and purple hues. This natural light show is not just a static display, but an ever-changing dance of lights. The intensity, color, and movement of the auroras can vary night by night and even minute by minute. This dynamic nature adds to the mystique and allure of the northern lights. The phenomenon of atmospheric fluorescence is a testament to the energy transfer processes in the universe. It showcases how cosmic and terrestrial forces come together to create something truly magnificent. This interplay of energy not only lights up our sky but also deepens our understanding of the natural world. Section 5: The Colors of Auroras, a Molecular Symphony. The vibrant colors of the Aurora Borealis are a result of different molecules in the atmosphere reacting to solar wind particles. Oxygen and nitrogen are the primary contributors to the colors seen in auroras. The specific wavelengths of light emitted by these molecules depend on their energy levels and the type of collision they experience. Oxygen, the most abundant molecule in the ionosphere, is responsible for the green and red colors often seen in auroras. When oxygen molecules are excited at lower altitudes, they emit a greenish glow. At higher altitudes, the same molecules can produce a reddish hue. This variation occurs due to the differences in energy levels and atmospheric pressure. Nitrogen, another key player, contributes to the blue and purple colors. When nitrogen molecules get excited, they emit a blue light. If these molecules are ionized before they emit light, the resulting color can be a deep purple. The interplay between oxygen and nitrogen creates the stunning array of colors that dance across the night sky. The specific conditions of the atmosphere, such as temperature and density, also influence the colors and intensity of the auroras. These factors determine the altitude at which the collisions occur and the type of light that is emitted. This molecular symphony is a beautiful demonstration of the complexity and beauty of nature. Viewing the Aurora Borealis is a dream for many nature enthusiasts and travelers. The best places to witness this phenomenon are near the polar regions, such as northern Norway, Iceland, and Canada. These locations offer long, dark nights and clear skies, perfect for observing the northern lights. Timing is crucial when it comes to viewing auroras. The best time to see them is during the winter months when the nights are longest and the skies are darkest. However, auroras can also be seen during the equinoxes in March and September when solar activity is high. Checking solar activity forecasts can help increase the chances of catching a spectacular display. For an unparalleled view, one can look to the skies from the International Space Station. Astronauts aboard the ISS have the unique opportunity to witness auroras from above the atmosphere. This vantage point offers a breathtaking perspective, showcasing the full expanse and beauty of the Aurora Borealis. Whether viewed from Earth or space, the experience of witnessing the northern lights is awe-inspiring. It reminds us of the incredible forces at play in our universe and our small yet significant place within it. The northern lights are a natural wonder that captivates and inspires all who see them. The Aurora Borealis has held a place of wonder and significance in various cultures throughout history. Indigenous peoples in the Arctic regions, such as the Inuit and Sami, have long revered the northern lights. For the Inuit, the auroras were believed to be the spirits of their ancestors playing in the sky. They saw the lights as a bridge between the earthly and the spiritual realms. In Norse mythology, the northern lights were thought to be the reflections of the Valkyries' armor as they led fallen warriors to Valhalla. The lights were seen as a symbol of bravery and honor, guiding the souls of the deceased to their final resting place. This mythological link highlights the deep connection between the natural world and human belief systems. In some East Asian cultures, auroras were considered to be celestial dragons flying across the sky. These dragons were seen as powerful beings that brought good fortune and prosperity. The appearance of the northern lights was a cause for celebration and reverence, symbolizing the presence of divine forces. The cultural significance of auroras is not limited to ancient times. In modern times, the northern lights continue to inspire art, literature, and music. They serve as a reminder of the beauty and mystery of our natural world, bridging the gap between science and culture. In contemporary times, the northern lights have inspired a wide range of artistic and scientific endeavors. Photographers travel to remote locations to capture the perfect shot of the auroras, showcasing their beauty to the world. These images often appear in scientific publications, travel guides, and social media, spreading awareness of this natural wonder. Artists have also drawn inspiration from the Aurora Borealis, creating paintings, sculptures, and digital art that capture the essence of the lights. These works of art often evoke a sense of wonder and serenity, reflecting the emotions experienced when witnessing the northern lights firsthand. In the scientific community, studying the northern lights has led to a deeper understanding of space weather and its effects on Earth. Research on solar winds and the ionosphere has provided valuable insights into how our planet interacts with the sun. This knowledge is crucial for protecting satellites and communication systems from the effects of solar storms. The Aurora Borealis also plays a role in tourism, attracting visitors from around the world to places like Iceland, Norway, and Canada. This influx of tourists supports local economies and promotes cultural exchange. The Northern Lights are more than just a beautiful display. They are a source of inspiration, knowledge, and economic benefit. The Aurora Borealis is a testament to the beauty and complexity of our universe. From the charged particles of the solar wind to the interaction with Earth's magnetic field and atmospheric gases, the Northern Lights are a manifestation of cosmic forces. They remind us of the intricate connections between the Sun and our planet. Beyond their scientific significance, the Northern Lights hold a special place in human culture. They have inspired myths, art, and scientific discovery, bridging the gap between the natural world and human creativity. The Aurora Borealis is a source of awe and wonder, captivating all who witness its dance across the night sky. In our modern world, the Northern Lights continue to inspire and educate. They are a reminder of the power and beauty of nature, encouraging us to explore and protect our planet. The Aurora Borealis is not just a light show, it is a celebration of the dynamic and interconnected nature of our universe. As we gaze upon the dancing skies, we are reminded of our place in the cosmos. The Northern Lights connect us to the Sun, to Earth, and to each other. They are a symbol of the magic that surrounds us and the endless possibilities that lie beyond.